Good day, my scholars. This is my school channel and my name is Abiola. For this video lesson, we are going to consider the measure of dispersion or variation. So right here, we are going to look into concepts like the relative dispersion or the absolute dispersion. So if you want to look into certain topics, like or subtopics that you can refer to as range, your deviations, your standard deviations, your mean deviations, and so much more like that. As well, under the relative measure of dispersion, you want to look at concepts like the coefficient, of mean deviation, the coefficient of variation, coefficient of quartile deviations. All of these are well packaged in this video lesson. All you just need to do is to relax, sit back, and don't go anywhere. Course will be right back. Yes, you're welcome back to my school YouTube channel, and right here we are looking into the topic tagged measure of dispersion or measure of variation. So at first, how would you describe dispersion? Dispersion means the distance of the scattered data from the mean or the average value. Remember that earlier we talked about a measure of center of tendency. So you are looking at how this data, right, or how these values are being scattered, right, from the measure of center of tendency. That is actually what we look at in measure of variation or measure of dispersion. So it's typically, or in just in simple terms, you can just say distance from the center. Do we see that now? So you are looking at how set of values, how similar they are to each other. So the more similarity, you are looking at, okay, they are less dispersed. The lower the similarity, you say they are far dispersed. So measure of dispersion is just the distance of scattered data from the mean or the average value of the data, or from the measure of central tendency. So let's move on to the next slide. Okay, so we have another definition here. So earlier, we've seen the mean, the median, the mode is usually not by itself a sufficient measure to reveal the shape of a distribution, of a data set. This is very accurate. Okay, so we also need a measure that can provide some information about the variation among this data set value. So you want to say, okay, what can give us more information, accurate information, precise information regarding some variation, right? Variations amidst this data set. All right, so the measures that help us to know about the spread of data, spread of data from the center, from the measure of center of tendency, we call them the measures of dispersion. Okay, so the measure of central tendency and dispersion, when you take them together, what do you have? You have a better picture of a data. Remember that it's a measure of central tendency, you are looking at how a single quantity will give you a picture, right, of the center. Do you see that now? So we consider three measures of dispersion. Of course, there are more, but we have range, we have variance, we have standard variation. So I think as we go forward, right, you see that we have range, of course. We have our variance, we have a standard deviation, we have your mean deviation, you have your quartile deviation as well. So let's move right to the next slide. Okay, so what is the purpose of measuring dispersion or measuring variation? So a measure of dispersion appears to serve two purposes, all right? There may be more, but let's just work with this. Okay, first, it is one of the most important quantities used to characterize a frequency distribution. So you recall our frequency distribution, it can be grouped. Okay, so second, it affords a basis of comparison between two or more frequency distribution. So it allows you to compare, two or more frequency distribution together. Then we have the study of dispersion bears its importance from the fact that various distribution may have exactly the same averages. So imagine that I have a set of data, probably 1, 2, 3, 4, 5, and I have some like this, probably 6, 7, 8, 9, 10. By the time you find their average, they have the same thing. So you can say that even though the set of the data, the member data there, they are different, right? They now still amount, just for instance, they now still amount to the same average. So you can see this is where measure of dispersion comes in. So I take this again. So the study of dispersion bears its importance from the fact that various distributions may have exactly the same averages, but substantial differences in their variability. So that is what it looks deeper into the concept of data giving. So let's move on to the next slide. Yes, so we have measures of dispersions or measure of variation. So we have the absolute measure, right? And we have the relative measure. Some can give you as the coefficient of dispersion. Okay, this. So under the absolute measure, we have the range, we have the quartile deviation, we have the mean absolute deviation or the mean deviation, if you want to put. We have the standard deviation, of course. Then we have, for the relative measures, we have the coefficient of variation, we have the coefficient of quartile deviation, we have coefficient of mean deviation. But basically for this video, I think I'm going to work more. This is more relative. I'm going to work more on this absolute measure. Of course, we're going to bring in one or two of these, but this is what we're really going to work on together. So let's move right to the next slide. So you can see there are two types of measurements of dispersion. We have the absolute and the relative, like I mentioned earlier. So an absolute measure of dispersion is one that measures dispersion in terms of the same units or in the square of units as the unit of the data. What it's saying simply is that one way you can use to differentiate between your absolute and relative measures of dispersion is that you will notice in your absolute you will have your units, right? Then for relative, no unit is really applied. So basically, when you are looking at your absolutes right here, your absolute, you are working in the same unit. Let me just put it that way. You are working in exactly the same unit. So it is possible that when you are working around this, you may not see this feature appear right here. So in your absolute measure of dispersion, you realize that you are working the same. Look at an example here. For example, if the units of the data are in rupees, they are in meters, they are in kilometers, etc. The unit of the measure of dispersion will also be in rupees, meters, kilograms, respectively. Do we see that right now? So let's move on to the next slide. Okay, so we're just trying to emphasize the concepts that we have before. So measures of dispersion, like I stated earlier, it indicates the extent to which individual items in a series are scattered about the average, the distance from the center. So distance from the measure of central tendency or measure of location. Remember that. Okay. So you can see earlier we mentioned the measure of absolute dispersion and the measure of relative or coefficient dispersion. So this is used to compare two or more data with the same means and the same units of measurement. So you can see used to compare two or more data with different means and different units of measurement. So you can see, so right here, one thing that you can use to distinguish between them is that you are going to be using the same unit. This can be squared, this can be, but the same unit in absolute measure of dispersion. So let's move ahead to the concept we have under absolute measure of dispersion. Okay, so at first we kick off with the range. Okay, so we can see it is the simplest method of measurement of dispersion, the simplest. So range defines the difference between the largest and the smallest value or observation, okay, or item in a given data distribution. So whatever thing you are observing, so you are just looking at a range, the biggest minus the smallest, or the largest value minus the smallest value. So what are the advantages? The prime advantage of this measure of dispersion is that it is easy to calculate and simple to understand. So probably if you have a set of given data, you just look for the number with the highest, look at the member with the highest value. Okay, then you look at the member with the lowest value, then you take their difference. So you see that you get your range. So you can say no special knowledge is needed while calculating range and it requires least time for computation. Hence provides just a broad picture of the data at a glance, just a broad picture, nothing specific. Alright, so let's look at the demerits. So it is very sensitive to outliers and significantly affected by fluctuation of sampling. So as the sampling fluctuates, remember we have our sample, we have our population. Okay, so it does not use all the observation in the data set and cannot be calculated in case of open-ended series. Do you see that now? So imagine that you imagine the concept of range. You just pick the highest and the lowest. So what about those ones in between? You're telling them that they are less relevant to whatever thing that is happening. So even though it has its own merits, these are some of the merits that we should be informed of. Okay, so we have it is crude measure because it is more informative to actually provide the minimum and the maximum value rather than providing the range. Do we see that now? So it is actually crude. So move ahead to the next slide regarding the range. So right here we have some examples. Again, we have the range is used to measure how widely spread a set of values are. So like I mentioned earlier, the largest value minus the smallest value. Then for range, you can also say the highest value minus the lowest value. Like so, look at an example here. So Steven played 12 holes at his local golf club and recorded his score. So what was his range of score? So basically we just look at the highest value. So if you look at all the members that we have here, what is the highest value there? We have 9, or the biggest value we have 9. Then what's the smallest? We have 2. Do we see that? So that is 9 minus 2. So you can see how spread it is. The same thing here. The next day he played under 12 holes. What is the range of scores now? So what is the highest value? That is 13. we have it here, and the smallest is 1, so you can see the range is actually 12. We see that now. So that is being informed. So let's move on to the next slide. Yes, so after the range, we can talk about our mean deviation. So earlier when we were working with measure of location, we talked about deviation, mean deviation. All right, so I'm going to explain this. So the average deviation or the mean deviation, they actually mean the same thing. So why the range is based on the highest and the lowest values in a distribution. Now, the average deviation or mean deviation is influenced by all the individual observation, like all of them, they are involved. So it is the average amount by which any value in a distribution differs from the mean. I'm going to explain this, of course. Let's move on to the next slide. So mean deviation is an average of your absolute deviation, right, of individual observation from the central value of a series. So we have this. Right, so let me just tell you what this means. So like for instance, if you have a set of data, right, let me say 1, 2, 3, 4. So if you look at 1, 2, 3, 4, by the time you add it up, 1 plus 2, that is 3, 3 plus 3, that is 6, 6 plus 4, that is actually 10. Okay, so let's say I'm adding 5 to it. So 10 plus 5, that is 15. So I have 1, 2, 3, 4, 5. Their total sum is actually 15. So how many are they? 1, 2, 3, 4, 5. So 15 divided by 5, that is 3. You can see their mean is 3. So by the time I now take a particular assumed mean, right? So how well is 1 deviated from the assumed mean or from the mean? So 1 minus 3, that is 2. Do you see that now? So in mean deviation, you don't take account regarding the signs, whether your deviation comes out as negative or positive. Do you see that now? So I have 1 minus 3, I've taken my mean to be 3. So 1 minus 3, that is 2. 2 minus 3, that is minus 1. 3 minus 3, that is 0. 4 minus 3, that is 1. 5 minus 3, that is 2. Do you see that now? So these answers I've gotten. So I will find their mean. Do you see that? I will add it together, then find their mean. So that is for your mean deviation. So how each individual, right, is scattered from the mean or from the assumed mean or the coded factor you have decided to use. Do you see that now? So that is actually mean deviation. I believe this will be clearer as we go further in the video, whether I use examples to provide a more fundamental or expository explanation. So basically when you have your data, you have picked a mean. How each member of the data, right, differ from the mean you have picked. Do you see that? Or the mean you have or you are using, right? So once you have not done that, you will now find the mean of those values, and that gives you your mean deviation. All right, so let's move on to the next slide. So we have our quartile deviation. So quartile deviation is similar to range, but it uses values in the middle half of the distribution rather than the end point. So poor measure when wide dispersion in the tails of distribution. So let me just explain this. So remember that we have our quartile. Remember, in our measure of location, we have our lower quartile and our upper quartile. Your lower quartile, your first quartile, that's your Q1. And your upper quartile or your third quartile, that's your Q3. Do you see that now? So if I want to refer to my interquartile range, that would be the upper quartile minus the lower quartile. That is Q3 minus Q1. Do we see that now? So that is my interquartile range. We see that now. So, or I can say, definitely that's just it. Or I can say my upper quartile minus lower quartile, or third quartile minus the first quartile. That's the same thing. Q3 minus Q1. So when I now have my Q3 minus Q1, both of them divided by 2, that difference divided by 2, that's actually my quartile deviation. Or I can refer to it as my semi-interquartile deviation. Some will tell you semi-quartile deviation. So it's basically your interquartile, right, divided by 2. That is Q3 minus Q1 over 2. Do we see that now? So that's where we have your quartile deviation. Let's move on to the next slide. Okay, so sometimes called the semi-quartile range, right? It is a spread of the middle 50% of the scores around the median. So the median, what we call the median? The middle value. Okay, so extreme scores will not affect the quartile deviation because anything those are some of the weaknesses that we should take note of. Like in quartile deviation, values that come before the Q1, they are not considered. Values that come after the Q3, they are not relevant. Do we see that now? So, but of course they have their usefulness. Characteristics, it uses the 75th, which is the upper, and the 25th, which is the lower percentile. So to put now. So difference between these two percentiles is referred to as your interquartile range. Do you see that I mentioned this? So the average of this, right, will now give you your semi-interquartile range or your quartile deviation. So it indicates the amount that needs to be added to and subtracted from the median to include the middle 50% of the scores. The thirdly, usually not used in additional statistical calculations. Okay, these are some characteristics. Let's move ahead, of course. Yes, so I have my quartile deviation formula. So like I mentioned earlier, your upper quartile minus your lower quartile divided by 2. All right, so you can refer to this as your semi-interquartile range, to put it that way. So you can see your third quartile minus your first quartile divided by 2. Okay, so this is just something to just show us proof. Let's move right to the next slide. So recall that I mentioned, the relative and the absolute measure of dispersion. So if this is your quartile deviation, then its coefficient will just definitely be this over this. Do we see that now? So we have Q3 plus Q1. Don't worry, as we move further in the video, I'm going to explain this. It's just a brief introduction to coefficients of quartile deviation. So we have definition of variance. So we are talking about absolute measure of dispersion. We've talked about range, we've talked about mean deviation, we've talked about quartile deviation, right? Then right now we are coming to variance. Okay, so the variance is a positive quantity that measures the spread of the distribution of the random variables about its mean value. I'm going to explain this. It's very easy. So larger values of the variance indicates that the distribution is more spread out. So what is your variance talking about? Typically your variance is just telling you that, okay, once you have gotten your mean deviation, right, you find your arithmetic mean of your mean deviation. Okay, so once you have done that, then you carry out your square. So don't worry, I'm going to use example to do that. So once you have gotten your mean deviation, you square it. Once you have squared it, then you find your arithmetic mean of that particular expression. Then you get your variance. Of course, like I said earlier, I'm going to explain this using examples. Let's move on to the next slide. Okay, so you can see this is your variance. Okay, part 2. Then we have your standard deviation is this. So basically what this is telling you is that your standard deviation is the square root of your variance. All right, so I'm going to show us this. Your standard deviation is the square root of your variance. So if your variance is 4, your standard deviation will be square root of 4, and that is 2. The next slide. Okay, so how do we define standard deviation? So statistics that measures the dispersion of a data set relative to its mean and is calculated as the square root of the variance. Like I mentioned earlier, some of the tools we refer to, in measure of dispersion, like our range. So you can see the defect with our range. You can see, so it doesn't take into consideration the other members, right? The other members of the data set. We see that. So that makes range quite inefficient, right? Then when we come to our mean deviation, even though it brings them together, it neglects the sign. So neglects the sign regarding the deviation produced from each member set when compared to the average value, right? So then when we come to our quartile deviation, your quartile deviation, you realize that the values or the members before the first quartile and the ones above the third quartiles, they are not put into concentration. Do we see that? So it's not good enough. So right here, your standard deviation has done a very wonderful job. Right, so it's actually bring everything together, considering the concept of variance, then it finds the square root of variance. So we can refer to our variance as, take this as your mean square deviation, or you can say your mean deviation squared. Do we see that now? So your standard deviation will now be the root of the variance of the root mean squared. So like I mentioned earlier, your variance is actually your mean deviation. Once you have gotten your mean deviation, you square it. Then the arithmetic mean of that square that you have gotten, that is your variance. So you can refer to it as mean deviation squared. Do you see that now? Or your mean squared deviation. That is how it is put in our resources that we are using, right? So your standard deviation will now be the root mean square or the root of your variance. Let's go ahead to the next slide. Okay, so you can see your standard deviation. So what you have inside is a typical sample, right? Just a typical expression of your variance. So your standard deviation now will now be the square root of this. So you can see explanations provided to the symbols that we have right here. Let's move ahead for the next slide. Okay, so we've mentioned the absolutes, right? We are done with absolutes. Then we want to consider some coefficient or the relative, okay, measure of dispersion. So the first one there should be the coefficient of range. So the coefficient of range is a relative measure corresponding to range, and it's obtained by using the following formula. It's just very easy. So once you have found your range, so you can see the largest value, this is your range now. So it will now be your largest value plus your lowest value times 100. That's your coefficient of range. In short, this is the typical setting that we are going to. So if it's going to be coefficient of range, it will be your range over this. It's going to be coefficient of mean deviation. What will it be? It will be your mean deviation over your mean, or if you want to use median to put, right? So your coefficient of your variance or variation, or coefficient of standard deviation will typically be your standard deviation over mean. Do we see that? So I'm going to say that in the next slide. So where L and S are respectively the largest and smallest observation in the data set. Let's move ahead for the next slide. Okay, so we see a summary of the formulas, right? So regarding absolute measure of dispersion and relative measure of dispersion, all the coefficients of dispersion. So look at your range typically. So you can read your largest minus your smallest. But right here in coefficient of range, you can see we have your largest minus your smallest over this plus this. Do we see that? So let's come to your quartile deviation or your semi-quartile, okay, range. So we have this Q3 minus Q1 over Q2. But right here, for your coefficient, it will just be this. So Q3 plus Q1. Do we see how all of these are coming up? So we have your mean deviation. You can see it this way. Then your coefficients will actually be your mean deviation over your median, or if you want to use your mean, I think we are still good to go. Then we have your standard deviation. It will definitely be your coefficient of your standard deviation will give you your standard deviation over your mean, right? Standard deviation over your mean. So you can see wherever the coefficients are being involved, you have to put forth that same expression. If you are dealing with range, your range comes first, your deviation, it comes first, your mean deviation, the mean deviation comes first, then this comes first. Then we look at your variance. You can see the relationship between variance and standard deviation. So for your variance, you can see the value we have. Then for the formula for the coefficient of your variance, typically to just be your coefficient of standard of deviation times 100%. So it's just your coefficient of standard deviation is SD over mean, which is this, right, times 100. So whatever value you have gotten from here, just multiply it by 100. So on a normal day, it should have been your variance is actually gotten. Your variance is you're going to produce your standard deviation by finding the square root of it. Or if you want to put it in another term, you can say your standard deviation is square root of your variance. But when it comes to their coefficient of dispersion, to just be that whatever thing you have gotten for your standard of your coefficient of standard of deviation, you will multiply it by 100 to give you your coefficient of variance. So right here, we've come to the end of the introductory part regarding measure of dispersion. So do not forget that for you to have access to the full video session, you need to click on the link in the description below. This is going to get you to the My School website. Right there, you get the instruction for you to get your subscription to have access, total access. So all you need to do right now is to also hit that like button for us, click on the subscribe button, and always tap on bell notification for you to get informed immediately we upload the next video content just for you.